Hello, hello. Today we're going to move on to Unit 3, Lesson 17. We're going to talk about equivalent expressions. So we still have our variables, we still have our coefficients and our constants. Now we're going to be able to write them as equivalent expressions. So writing the same thing in a different way. So let's use what we know. Write an expression that is equivalent to 3 plus 14 plus 27. A says, which two terms in 3 plus 14 plus 27 could you add to get a multiple of 10? So which of these two numbers could we add together that would give us a multiple of a 10, or a number that ends with a 0? In this case, we would do 3 and 27, because they would add to 30, which is a multiple of 10. So B says, rewrite the expression so that these two terms are next to each other. So we could write 3 plus 27 plus 14. C, did rewriting the expression change its value? No, because the order does not, that's a little sloppy, let's try that again, does not change the value. Doesn't matter what order we add them, we're still going to get the same answer. So D says rewrite the expression with parentheses to show that the two terms with the sum that is a multiple of 10 should be added first. So parentheses say I come first, so we would just put the 3 plus 27 inside the parentheses and then add the 14 to the end. E, did rewriting the expression change its value? Explain. Just like up above. No, it did not. Because our original expression, 3 plus 14 plus 27, is still equal to our second expression, 3 plus 27 plus 14. They equal the same thing. The order does not change the value. F, what is the common factor of the number in parentheses? So let's look at the one we just wrote. So we're going to look at this one right here. 3 plus 27 plus 14. So if we're looking at our two numbers in the parentheses, what is the common factor of 3 and 27? If we worked it out to find our greatest common factor, we would find that it would be 3. So G says, rewrite the expression so that it is a number plus the product of a number and a sum. So that's a little confusing, so we'll just break it down a little bit. So we're going to take and we're going to add our 14 here, okay? And we're just adding it. It's staying separate from what's inside our parentheses. So now we need to take, and we're going to use the distributive property. We talked about this when we were dealing in Lesson 11 with our greatest common factors. If I take my 3, so I have 3 plus 27. If I write these as multiplication problems, so 3 times 1 would give me 3, and I add 3 times 9 because it gives me 27, I can now take my common factor that I said that we have up here, the 3, and I can pull that out. So I'm going to take and I'm going to pull out my 3. When I do, what does that leave me with in parentheses? It leaves me with a 1 plus a 9. So that right there is the product of a number and a sum. So we would do 3 times 1 plus 9. H, does rewriting the expression this way change its value? Which property of operation supports your answer? Well, I kind of snuck ahead of you because I brought it up already. But which property of operation supports your answer? It's the distributive property. And does it rewriting it change our answer? No, it doesn't change the answer. The value will still be the same. I, explain why you might want to write an equivalent expression. Well, depending on how you write it, it could make it easier. Okay, so let's go through and find out a little bit more. In the problem on the previous page, you applied properties of operations and expression with all constant terms to create equivalent expressions. So, you can see here we have three different properties. The first one is the commutative property of addition. This is what we did up at the top. It's reordering the terms, does not change the value of the expression. Okay, so this is our vocab words here, so we need to make sure that we get these. Reordering the terms does not change the value of expression. It does not matter if we do 3 plus 14 plus 27, or if we do 14 plus 3 plus 27, or like on the previous page, we did 3 plus 27 plus 14. No matter what, when we are adding, it doesn't matter what order we do it in, we should still get the same answer. The next one is the associative property. And the associative property, it is saying that it doesn't matter where the parentheses go, which two we add first, the value will not change. So the associative property, regrouping the terms, does not change the value of the expression. So it doesn't matter if we do 14 plus 3 and then add 27 to it, or if we do 3 plus 27 and then add 14 to it. It will all be the same. The last one is the distributive property, and this is the one that we talked about in class with lesson 11. So it says distributing the common factor does not change the value of the expression. So when we took our 3 and 27 and we pulled out our common factor of 3 and did 3 times 1 plus 9, that is the same thing as if we just added 3 plus 27. The same is true for expressions with variable terms. You can apply properties of operations to a variable expression to create equivalent variable expressions. So, we have the same three properties here, only now they've actually thrown in some variables. It doesn't change how the property works. So 3x plus 14 is the same thing as 14 plus 3x. For the associative property, it doesn't matter if we added 14 plus 3x first or if we added 3x plus 27 first. And then for the distributive property, 3x plus 27 is the same thing as if we pulled the 3 out and multiplied it times x plus 9. And we'll go into more detail on all of these as we go through this lesson. So number 1 says, Henry says that you can apply the commutative and associative properties to 5x plus 10 and get 10x plus 5. Is Henry correct? Explain. So let's look back up here for just a quick moment. Down here it says 5x plus 10 is the same as 10x plus 5. What do you notice is happening with our variable? Here it's connected to the 5. Here it's connected to the 10. But if you notice, whenever we are using the commutative and associative property, does our variable change numbers? No, it does not. So our answer down here would be, is Henry correct? No, because 5x is a term. The properties say you can reorder or regroup the terms without changing the value, but he actually changes the factors. The property says you can reorder or regroup the terms, and then we're going to go up here, but he changed the factors. Okay, so you can't move where the variable is as far as what number it is attached to. If the variable is attached to the 5, it has to stay with the 5. All right, so let's talk about properties of operations a little bit more. The problem says Jamie has 4 bags of apples. Ashley has 3 bags of apples. Each bag has the same number of apples in it. Write an expression for the total number of apples, then simplify it to create an equivalent expression. So, in the first example, the picture it says draw a picture of the bag of apples. So, we don't know how many apples there are. So, if you look here, it shows that there's X number of apples in each bag. So, you can see Jamie has 4 bags and Ashley has 3 bags. For the second one, model the bags with math tiles. So basically, instead of drawing the bags, we're just drawing X's. So you can see Jamie has 4 X's here, or 4 tiles, and Ashley has 3, and in each one of them, you can see that there's X number of apples. So let's connect it and go through some questions now. Number 2 says, in both the picture it and model it on the previous page, what does the X represent? Well, our X is our number of apples in each bag. Number 3, write an expression for Jamie's total number of apples. So, there are 4 bags for Jamie and there's X number of apples in each. So we would write that 4 times X, or 4X. Remember, side by side means to multiply. Do not use the X for your multiplication symbol. It is no longer an option. You need to be using either the little dot or write them side by side, because X now is a variable. Write an expression for Ashley's total number of apples. Well, Ashley had 3 bags with X number in each one, so we would write that as 3X. Now, write an expression for the combined total of Jamie and Ashley's apples. Well, if we're combining them and we're wanting a total, we're going to be adding. So you would write 4X plus 3X. When 2 or more like terms in a variable expression have the same variable factors, they are called like terms. You can use the distributive property to simplify an expression with like terms. So, basically what that means is if you have a common variable, for example, like 4X plus 3X, X is common, so we can actually call those like terms because they are basically the same type of number. So number 4 says, what is the common factor for each term in your expression from problem 3? Well, our common variable is X. 5 says, distribute the common factor and simplify the expression. So, remember, when we are using distributive, we're taking that common factor out. So, if I have 4X plus 3X, and I take and I pull out the X, it's going to give me X, and I'm going to be left with 4 plus 3. Now, I can work my way through and simplify. What is 4 plus 3? It's 7. So I can take and I can simplify, and now I have X times 7. Or I can rewrite that as 7X, because that also means to multiply. Number 6, what does the simplified expression mean? There are 7 bags with X number of apples in each. So number 7, explain how to simplify the expression with like terms such as 6G plus 5G. Well, we do the same thing as we did up above. Factor out the common factor and then simplify. So if we have 6G plus 5G, our common factor is G, so I pull that out. I'm left with 6 plus 5, so now I can simplify. 6 plus 5 is 11, so I have G times 11, which is 11G. So now I want you to try it. Use what you just learned about writing equivalent expressions to solve these problems. So take a moment, pause the video, work your way through. Both of these are just like what we did together with 5 and 7. So you're factoring out your common factor and then simplifying. Here in a few moments, once you finish it, resume the video to check your answers. Okay, so on number 8, the cafeteria has 30 boxes of Wheaties Squares cereal and 20 boxes of Mighty O's cereal. Each box has the same number of ounces of cereal. Write an expression to represent the total ounces of cereal, then simplify to create an equivalent expression. So, 30 boxes of Wheaties cereal. And then there's 20 boxes of Mighty O's. Each one has the same number of ounces of cereal, but we don't know what that number of ounces is. So we have to use our variable for that. So 30 boxes at some number of ounces each, and then 20 boxes with some amount of ounces of each. And if we're trying to find the total ounces of cereal, you would add. So now we have our setup 30x plus 20x. So now I need to write an equivalent expression. I do that by factoring out my like factor. In this case, it's my x. So if I pull out my x, I'm left with 30 plus 20. Now I need to simplify. 30 plus 20 is 50. So now inside I have x inside my parentheses 50, which simplifies to 50x. Number 9, the inspector at a bottling plant checks 25 bottles. 2 bottles do not pass inspection. All the bottles hold the same number of milliliters of sports drink. So we have 25 bottles, 2 do not pass. All the bottles have the same number of milliliters. We don't know how many milliliters that is. So I would have my 25 bottles with X number of milliliters, and I have my 2 bottles that did not pass with X number of milliliters. What would I need to do with those? If I'm saying they don't pass, I say I'm subtracting. So even though I'm subtracting now instead of adding, my process is the same. Find my common factor, which is x, so I write my x. That leaves me with 25 minus 2. Now I can work my way through and simplify. So I have my x, 25 minus 2 gives me 23, and then that gives me 23x. Okay, the next problem says Xavier creates a rectangular painting. The painting is 3 feet long and more than 2 feet wide. The expression 3 times 2 plus x represents the area of the painting. write an expression equivalent to 3 times 2x. So in the model it, the multiplication expression 3 times 2x means 3 groups of 2 plus x. So we can use math tiles to model this. So you can see that here's 1 group, 2 groups, and 3 groups, and each one has 2x in it. So then we can take and regroup the tiles so that we have all the 2's together and all the x's together. So now we can compare the 3 times 2x, 2 plus x, sorry, and you see that we have 2 plus 2 plus 2 and x plus x plus x. Or in the picture it says draw and label a picture of Xavier's painting. Imagine dividing the painting into 2 smaller rectangles. So we have our 3 feet high, and we have our 2 feet plus the x number of feet here. So now we're going to answer some questions. Number 10 says, the expression 3 times 2x is a product of the factors 3 and 2 plus x. Because when they're side by side like this, it means to multiply, which means we're finding the product of. Number 11, in model it, what expression is equivalent to 3 times 2 plus x? Well, it showed us at the bottom of the model it. It said it is equivalent to 2 plus 2 plus 2 plus x plus x plus x. So adding 3 2's is the same thing as 3 times 2. Adding 3 x's is the same as 3 times x. 12, look at the picture. Explain why the area of the whole painting is 3 times 2 plus x. So for this one, we have to think back. To find the area, it's length times width. So it showed us that our length is equal to 3 feet, and our width is equal to 2 feet plus x, some number of feet there. So it would be 3 times 2 plus x. Number 13, and picture it, the area of the left side of the rectangle is 6. Because we're coming up here, the left side is 3 times 2, which is 6. The area of the right side is 3 times x, or 3x. Write an expression for the area of the whole painting. So the area of the left side plus the area of the right side would give us 6 plus 3x. 14. Compare 3 times 2x to the equivalent expression in 13. What property did we apply? So if we had 3 times 2 plus x, and we know it is equal to 6 plus 3x, how do I get from here to here? Well, I'm basically taking my 3 and I am distributing it back in. So that means that it is the distributive property. So with number 14, we kind of actually worked it ahead earlier, and we simplified the expression from problem 14. Well, we knew that we took 3 times 2 plus 3 times x, and that's what gave us our 6 plus 3x. So we kind of did that ahead of time up with number 11. 16, is 3 times 2x equivalent to your simplified expression? Explain. Yes, it's equivalent because applying properties of operations does not change the value. And if we were given a total for x and we plugged it in, no matter which expression we used, we would get the same answer. So now you try it. Take a couple moments, work out 17 and 18 using the distributive property, and then when you've done, go ahead and resume the video to check your answers. So for number 17, we are distributing the 5 back into the problem. So if we have 5 times 2x minus 1, I'm going to take the 5 and I'm going to multiply it by each term. So I'm going to start with 5 times 2x. Well, 5 times 2 is 10. X minus 5 times 1, which is 5. So the equivalent expression would be 10x minus 5. Number 18, on this one, we're finding our common factor and we're pulling it out. So, like we've talked about before, we have to find our greatest common factor of 18 and 24. So 18, we could do 2 and 9. 9 would be 3 and 3. 24, we could do 2 and 12. 2 and 6. And 2 and 3. And yes, you could work those out different, but you should end up with the same numbers. So we find our matches. I have a 2 here and here. That's 1, 2 in common. I have a 3 here and a 3 here. That's a 3 in common. Nothing else in common, so I multiply these. 2 times 3 is 6. So I factor out a 6 from 18 and 24. Okay, so 6 times 3 gives me 18, plus 6 times 4, and then we'll attach that x to it. So now I take and I pull out my 6's, and I put it in front, and I'm left with 3 plus 4x. So 18 plus 24x is equivalent to 6 times 3 plus 4x. So now we're going to be trying to determine whether expressions are equivalent. So it says, is 5h plus 2h squared equivalent to 7h? So in our picture it says imagine line segments that are h, some distance, 5h, and 7h units long. Okay? Imagine rectangles that are h squared and 2h squared. In area. And to model it, it says to use math tiles to model 5h, 2h squared, and 7h. So you can see, here's 5 h's on the left, and the middle you have 2h squared, because they're two-sided, and then you have 7h on the right. So let's go through some questions. Number 19 says, look at picture it. If you combine the line that is 5h units long and the rectangle that is 2h squared units in area, do you get a figure that looks like the line that is 7h units long? Obviously that's a no, because you're not going to take a square and make it look like a line. 20, look at model it. If you put the tiles representing 5h together with the tiles representing 2h squared, do you get the set of tiles that represent 7h? Once again, no. You're not going to take squares and make them into small rectangles. So, 21 says, Richard says that 5h and 2h squared are like terms because they both have the variable h is Richard correct? Well, if we look back at our pictures, do the h and the h squared look the same? No, they do not. For them to be like terms, they have to be exactly the same. Okay, so if you have h squared, it is not going to be the same as just an h. (22) Is 5h plus 2h squared equal to 7h a true statement? Substitute a value other than 0 or 1 for h and evaluate to support your answer. So, based off the pictures, we said no, because h and h squared aren't the same. Well, now they want us to prove it. So it says, do not use 0 or 1, but let's say that h equals 2. So let's take this 2 and we'll plug it in. So if we have 5 times h, which would be 5 times 2, plus 2 times 2 squared, let's solve this. 5 times 2, order of operations, start with your exponent. 2 times 2, or 2 to the 4th, is 4. Bring everything else down. Now we can multiply. 5 times 2 is 10. Bring everything else down. 2 times 4 is 8. Bring everything else down. And we have 10 plus 8, which is 18. If I take my 7h, it would be 7 times 2. 7 times 2 is 14. So does 18 equal 14? No, it does not. So that shows that they are not equivalent. I'm going to give you guys a second to make sure you get all this written down because I need to erase it so we can read the bottom. Okay, so now the bottom question says, apply the distributive property to write the expression that is equivalent to 5h plus 2h squared. Show your work. So if we write this out, and I'm going to do it over here to the side so we have a little bit more room. If I take 5 times h plus 2 times h squared would be the same thing as writing h times h. So now I have to look, what is the common factor that I have? Well, I have an h here and I have an h here. If I take and pull those out, it leaves me with 5 here plus 2h here. So equivalent would be h times 5 plus 2h. So now I want you to take a moment and try 24 and 25. Make sure to write whether or not they are equivalent, and then also use substitution to check your answer to make sure you're correct. Pause the video, take a couple moments. When you're done, resume it to check your answer. Alright, so let's look at 24. They want to know if 3x plus 6 plus x and 2 times 2x plus 3 are equivalent expressions. So the first thing I'm going to do is look at each one of my expressions and try to simplify them. When I look at 3x plus 6 plus x, if I look here, are my variables exactly the same? Yes, they are both x. So I can actually combine those. If I have 3 x's plus 1 more x, it gives me 4x, and then I can add my plus 6. For this one, I can use distributive property and I can distribute my 2 in. So I would do 2 times 2x, which would be 4x plus 2 times 3, which is 6. So based off this, I would say yes. Now I'm going to use the substitution to check. So I'm going to say that x is equal to 2. So I'm going to plug my 2 over for these. So if I have 3x, it would be 3 times 2 plus 6 plus 2 for my x. And over here, I would have 2 times 2 times 2 plus 3. So now I can simplify. I'm going to start over here. 3 times 2 is 6 plus 2. So then I know 6 plus 6 is 12 plus 2 is 14. Here, I'm going to start in my parentheses. 2 times 2 is 4. Bring everything else down. Then I'm going to stay in my parentheses. 4 times 3 is 7. Bring everything else down. And 2 times 7 is 14. 14 and 14 are equal. So yes, I am correct. They are equivalent. 25, I'm going to do the same thing like I did above. I'm going to distribute my 8 into my problem. So 8 times w is 8w plus 8 times 6 is 48. Here, I have 2 constants. I can add 5 plus 1, and it is a 6. And that means that my 8w would be added to it. So, based off this, I would say that no, they are not equivalent. But let's use our substitution to check. So I'm going to say w is equal to 2 once again, and I'm going to plug them in. 8 times w, which I'm going to be using 2, plus 6, and then I have 5 plus 8 times w, 2, plus 1. So 2 plus 6, starting in my parentheses, is 8. And then 8 times 8 is 64. Here, start with my multiplication. 8 times 2 is 16. Plus 1 and 5. 5 plus 16 is 21. Plus 1 is 22. So 64 and 22 are not equal. So my answer is correct with no, they are not equivalent. So now you need to get back into the classroom. You need to complete your exit ticket and submit. Once you have finished that, I want you to go ahead and turn the page and work on 174 and 175 in your instruction workbook.